Good morning, everyone. My name is Dr. Pratap. So I am working as an assistant professor in Mallareddy Engineering College. Today I am going to discuss about the topic isomerism. So what is isomerism? First of all, isomerism is the phenomenon that more than one compound have the same molecular formula, chemical formula or molecular formula, but differ in their chemical structures. That is isomerism. So there are two types of isomerisms are there: constitutional isomerism and stereoisomerism. Constitutional is nothing but structural isomerism. Stereoisomerism means, so it is depending upon the spatial arrangement, different arrangement of atoms or molecules in the space. That is called stereoisomerism. So again, stereoisomerism two types, that is geometrical isomerism and optical isomerism. You see, this is isomerism, structural isomerism. There are six type of isomerism are there: chain isomerism, functional isomerism, positional isomerism, metamerism, tautomerism, and ring chain isomerism. And stereo, I told you, stereo isomerism again two types, that is geometric and optical isomerism. So for example, we see the structural isomerism. What is structural isomerism? It has the same molecular formula but differ in their connectivity. So in their connectivity means, this is of for example, you see the skeleton of the carbon. See here this is straight chain, this is the branched chain. So this is the skeletal chain. So the skeleton chain isomerism, this type of isomerism is called chain isomerism. So the connectivity is different. So this is branched chain and this is long chain. So for example, another one is positional isomerism. So you see there's the position of the nitro group. Position of the nitro group, this is ortho position, this is meta position, this is para position. So position of the nitro group is here ortho position and here is para position. This type of isomerism is known as positional isomerism. So the molecule or the atom changes the position. So that is positional isomerism. So the molecular formula is same but differ in their position of the atom or molecule. So those type of isomerism is called positional isomerism. This is for another example, 1-chloropropane. This is the chlorine present on the first carbon, that is 1-chloropropane. So this is the chlorine present on the second carbon, that's why this is 2-chloropropane. The position of the chlorine is on the first carbon, here the position of the chlorine is on the second carbon. So this type of isomerism is called positional isomerism. Next one is functional isomerism. So here also the molecular formula is same but differ in their functional group. You see the functional group of here CHO aldehyde and this is C double bond O keto. So keto group. So aldehyde converted into keto group. So aldehyde and ketone has same molecular formula but differ in their functional groups. That is, one is CHO and another one is C double bond O. Next one is as ring chain isomerism. You see the ring chain isomerism. Propene. Here the propene structure and it converts into cyclopropane. So that is the ring chain. So this is in the form of chain. So this is acyclic, this is cyclic. So acyclic form converts into cyclic form. So this is also having the same molecular formula. This is also having the same molecular formula but differ in their structure. That is, this is cyclic structure and this is acyclic structure. So here the another example of functional isomerism, ethanol and ether. So ethanol and ether also, these are the functional isomerism. And you see the molecular formula C2H6O. Here also C2H6O. The molecular formula is same but differ in their functional groups. This type of isomerism is known as functional isomerism. So again, configurational, conformational. So due to rotation, configurational isomerism takes place. So without the rotation, that is, if there is any restricted rotation, then it is configurational isomerism. Then it is called as the configurational isomerism. So due to rotation, conformational isomers possible. So due to non-rotation, so that is a restricted rotation, so configurational isomers are possible. So here again, configurational isomerism, geometrical and optical isomerism. So what is the optical isomerism here? Here stereochemistry. Stereoisomers have the same atoms connectivity but differ in the spatial arrangement. Already I told you, we discussed space. In the space, the atoms are having same molecular formula but differ in their structure, connectivity or the spatial arrangement of the molecule or the atom in the space. So for example, here you see this is the C double bond C, C double bond C. So here the restricted rotation takes place. Why? Because if you rotated this carbon, so the double bond will be break. There may be chance for the breaking of double bond. So that's why there is a restricted rotation for this type of molecule. So that's why these type of molecules are called as configurational isomerism. If the rotation takes place, then that is called as conformational isomerism. If rotation not takes place, so the restricted rotation is there, then it is configurational isomerism. So again, configurational isomerism, two types, geometrical and optical. So this type of isomerism is called geometrical. So you see here CH3, the same or identical elements or groups are at the same side of the C double bond C. Then this type of isomerism is called cis isomer. So you see the CH3 are opposite side to the C double bond C. This type of isomerism is called trans. So this is cis and this is trans. So these are the conformational isomerism. So we will discuss later this conformational isomerism. So here geometrical isomerism. You see cis tube butane. Cis tube butane. The two methyl groups are present at the same side. So these are the methyl groups are present at the opposite side to the double bond. So that's why this is the cis form. This is the trans form. So cis tube butane, cis trans tube butane. So why? Because 1, 2, 3, 4 carbons are there. This is butane. That's why it's called as cis tube butane. So it's called as trans tube butane. So this is, you see, this is also cis and trans. Or here or same identical groups are present at the same side, and same identical groups are present at the opposite side. That's why this is trans form. If suppose the same identical groups are not present on the C double bond C carbon, so then what we have to do? You see the structure here. Cl group is present, here CH3 group is present, here H group is present, here bromine group is present, but we can't predict whether it is cis or trans. Then what we have to do? Then there is another formula, that is E form and Z form. So E form and Z form. So according to Kohn-Ingold predict rule, so we can give the priority of the molecule. So first priority of the molecule for the C bond. So here the C, you see there are some rules or Kohn-Ingold predict rule. So we will see the rules first of all. So this is the rule 1. So if suppose the group or atom has higher atomic number, then that has higher priority when compared to less atomic number. You see the iodine, bromine, chlorine, fluorine. So the atomic number of iodine is more than bromine, then more than chlorine, this type of. The rule 2. If suppose the atomic number is same, then we have to consider the mass of the atom. So you see the tritium and deuterium and hydrogen, isotopes of the hydrogen. These are having atomic number 1, but having mass. This has 3, this has 2, this has 1. So we have to give more mass. So the more priority to the more mass. Second one, if suppose all are having same carbon atoms. You see the carbon atoms, here C, here C, here C, here C. So then we have to compare the next element to the carbon. So the next element to the carbon is C, next to the carbon is Cl here. Here next to the carbon is oxygen. Here next to the carbon is nitrogen. Here next to the carbon is carbon. So you see chlorine atomic number is more when compared to oxygen. So oxygen atomic number is more when compared to nitrogen. So like this we have to give the priority of the molecule. Suppose next one, if suppose is there any double bond or triple bond, so then we have to give more priority to the double bond or triple bond. If suppose double bond and triple bond is present, then we have to give more priority, first priority to the triple bond and then double bond. You see the structure of this is you see E form and Z form. How we can distinguish E form and Z form? You see the C carbon, this is C1 and C2. We have to give the preference, more preference. CH3, here H3. As carbon has higher atomic number, hydrogen less atomic number. So we have to give more preference to the. So this is number 1, this is number 2. So you have to, then we have to compare these two. So bromine has higher atomic number when compared to chlorine. This is number 1, this is number 2. So 1 and 1 are in the opposite side. If say higher priority groups are opposite side, then it is called as E form. If higher priority groups are at the same side, then it is called as Z form. You see here, so this is the first priority and this is the first priority bromine and this is the first priority chlorine. So we have given close. Okay, here so the final conclusion is what is cis and what is trans. If two similar groups are on same side of the restricted bond, so that configuration is cis. If there are opposite side, they are present at opposite side, then it is called trans. So what is EZ? If the higher priority groups are on the same side of the restricted bond, so then it is Z, otherwise it is E form. So I am giving some examples. You see, so here CH3 and CH3, these are opposite side, then it is the trans form. So we can also denote it in the E form or Z form. So here see, the higher preference is here and higher preference is here. So higher preference are on the same side, so that's why the form is Z form. So the second example, you see the second example, here CH double bond CH2, CH double bond CH2 are on the opposite side, that's why this is trans. So now according to EZ formula, we have to give the preference. So this is double bond, this is triple bond. We have to give more preference to this. So this is first and this is double bond, this is single bond, we have to give this is first. So 1 and 1 are in the same side, so that's why the form is Z. Here you see there are 4 different atoms. So we can't predict according to cis and trans. Why? Because there is no any identical element or same element on the C double bond C. So that's why we can recognize only EZ form. So what is EZ form means? Again we have to give higher priority. Bromine and iodine has higher priority. Chlorine and fluorine has higher priority. So these are in the opposite side. That's why this is E form. So you see, this is not applicable cis and trans. Why? Because here bromine, chlorine, CH2O2, CHO. So these are the 4 different groups. So these are the 4 different groups means we can't predict a cis trans form. So we can give only EZ form. So here you see C double bond O is present. We have to give the higher preference to this molecule. So bromine and chlorine, we have to give the higher preference to the bromine.